All right, so one way of using the graphs is now I could even ask you for various other things. If you don't necessarily have the graph, obviously you notice that I kind of gave you a small graph here of cosecant down there. But you could look at your graph and go to negative 90. So where is negative 90? Well, look, down here I've got 1, 2, 3, 4 tick marks, right? And 4 tick marks is negative 180. So where is negative 90 is at 2 tick marks, right? So you kind of connect your dots here. So what is cosecant of negative 90? Now how do you tell? Well, there's 3 dots, right? So this one here is negative 2, that's negative 1. So it's supposed to connect. There you go. Straight across, goes up. It is negative 1. Okay. Why don't you try your graph right now that you just made today for tangent at pi? Use the one you made today or the answer one that I just gave you. Either way is fine. And find the answer for that one. All right, what'd you find out for tangent at pi? There it is. So where is pi on this thing? Well, notice I gave it to you in degrees. Here's 360. Is that pi?
No, it's 2.
Oh, this is pi right there, right? And so it is 0. Realize I obviously graphed these, had to kind of throw them in here, but you have your graphs already there. How about secant? Well, you could go to your secant graph now and look at negative pi over 2. Now, you might want to look at the answer one or look at the one we did yesterday. I'm guessing it's down here. I've kind of shrunk things up here. I'm only going from negative 180. So where is negative pi over 2, though? Negative 90. Oh, yeah. You see what I mean, how the graphing calculators don't actually graph the asymptotes? Because they're actually not part of the graph. So how do you answer that question? Undefined, yep. Let me see how I want you to answer that. Yeah, I'll take no solution. That's fine. Yeah. You can put asymptote, sure. Okay, so this is the graph of cosecant. All right, and I went to negative 90 degrees, which is where I put the first red mark. Maybe I'll get rid of that. So here's negative 90, right? Right, because negative 180 is all 4. See, 1, 2, 3, 4 tick mark. I didn't go to negative 360. No, I'm finding the y value. Y value is negative 1. Yep. On these, yes, you are finding y value because the angle is always on the x-axis. So it's always, if they give you the angle, they're asking for that. Obviously, I could ask this differently. I could ask where is cosecant negative 1, and you'd have to tell me where it happens. That's actually coming up next. So determine all, all values of theta for which the equation is true. So look at your sine graph. Was it ever negative 1? The one we did yesterday. Did it ever hit negative 1? Okay, so you're saying at negative 90 it was down there at negative 1, right? And you're saying at 270 over here it was at negative 1? Now it's saying all. Did it tell me to go from negative 360 to 360? Is that what the direction said? If that's what they said, I would have said negative 90 and 270, I would have been done. But do you agree they happen at regular intervals? They keep happening at the same amount of time. Well, what is kind of the distance between those? Well, this is negative 90, and then this is 270 going this way. So what is actual distance between the two is actually 360, agreed? Between the occurrences? So here's what I would do. You can pick either one you want. Whichever one you want to start at, it doesn't matter. So we'll say 270. So 270 degrees plus, and here's how you're always going to do these when they ask for all of them. Pick one of them to start with. It doesn't matter. Could I have picked the one that happened way over here? Yeah. I could have picked the one that happened way over here. I don't care. Pick wherever one you want. Probably pick the easier ones. And you just told me that it happens every 360 degrees, correct? Does it happen every 180 or no? 360 is the next occurrence. So you're going to add 360 degrees. Do you agree that would get me to another one? But wouldn't adding 720 get me to another one? Oh, so what we're going to do, and this is a very common way of doing it, we're going to put a K here, and I'll explain what that means. This is understood by a lot of mathematicians what K is, but you might want to make a note that K is an integer. So get that written down first, and then I will explain it. Okay, the question was, couldn't we do 270 plus or minus 360? Oh. No, because what's K? K is an integer, so 1 plus or minus 360? That does not get me to a place that's an answer. You can, yes. But I'll tell you why we only put plus, to save ourselves time. Yes? You could put X, but K is kind of understood as a universal letter to see at the end of these types of problems. And then you could use X, like you said, and then just say X is an integer. But let's remember what an integer is. Integers are positive and negative digits, correct? And so could K be, for example, -2 in this problem? And if I took 360 times -2 and then added 270, would that get me to another location that it is actually -1 for sign? Yeah. Or what if K was 17? Took 360 times 17 and then added 270. Would that be another place it happens? It does. And so that's why we don't put plus or minus in there, but you could. And say that you could put X, but K is kind of understood as to be the one that you will see people use. And then just make sure that people know K is an integer, because if it's not an integer, you don't get them all. Okay. So let's take a look. How about cotangent being 0? Does that ever happen at all? Because could I give you one that just never happened? I could do that, right? Well, yeah, cotangent I think is definitely 0 at some places. Anybody give me some few answers? I'd say right here is one. What's that one? Nope, I'd say it's 1, 2, 3, 4. You got to watch my numbers. 90, this is, so that's 90, that's 270. This is -90, -270, right? So what did I say? Just pick one of them. Does it matter? No. What are most of us probably going to pick? Probably 90, maybe 270. It doesn't matter. So 90 degrees. Obviously, if you're going to go radians here, you have to do it a little differently, and I can show you how to do that with the next one. Plus. Now, how do you figure out? Over here it was 360. How do we figure that out? Because that's how often it happened, right? If I use 360K on this one, will I get them all? No, I will miss some, won't I? I'll skip a lot of them. Because how often do they happen? 90 to every 180 degrees K. And again, K is an integer. What I will allow you to do in here, technically I should make you write that every time. I will allow you to not write that. We will say right now that if we see K in here in this chapter, we know that it means K is an integer. Watch out, if you go on to school, they may ask you to write that again now. But do you understand why it's important for it to be an integer? That's what I want to make sure. It could be positive or negative. Now on this one, you have to be careful. Let's say I told you to write this one in radians. Well, 90 is pi over 2. Can I say 360 degrees when I'm doing radians? No? Well, I can't even say 180 degrees when doing radians. What's the equivalent? Pi. Very good. Plus pi. K. You notice K doesn't change even if you go to radians. Okay, do you agree that that's really saying the same thing? Just in a different language, you could say. So any questions on that so far? Doing good? All right. We only have one more thing to talk about, and then we're done. Domain and range. Have you heard those words before? Yeah, most definitely in Algebra 2, and most definitely in Algebra 1, not so much in geometry. Anybody remember domain and range? Normally I just put a D and an R. Domain is the X values, yep, and range is the Y. Or some people do say domain is the first value and range is the second in case you have different letters than X and Y, which is fine. And so what we're going to try and do is list basically, and I'll either give you the graph or it's one that you'll have. So all X values that happen. So here your X values are actually the angles, right? So do you agree that this graph would continue going this way, it would continue going that way, and it would continue forever, correct? I just showed you a small portion of it. Are there any X values basically that don't get graphed? Or are there any asymptotes is really what you're looking for? Is there any that cause a problem? No. So what you say is all reals. We don't want imaginaries here. Okay, so any real number, for example, if I try 27 degrees, is there actually a Y value graph at 27 degrees? Yep. Could I pick 83 degrees? Is there still a Y value graph? Yeah. How about 1,000,002 degrees? If I went that far, would there be something graphed there? And there would. There's not an X value I can give you that you'd say, nope, no good. How about Y values? Does every single Y value here get graphed? No. Up to 2 and down to -2, right? So you're saying that 3 is never going to happen for a Y value? How about -2.5? Is that ever going to happen? How about -1.5? That happens actually quite a bit, right? So there are some that work and some that don't. Here's how I write it. You don't have to. I kind of throw the Y in the middle. And then I just kind of go like this. Keep your signs the same way. You can do it the other way if you want. So this is saying that Y has to be less than or equal to, well, what's the biggest Y can get? +2, does everybody agree with that? So Y has to be less than or equal to 2. Now you have to read this one the other way. You have to read it going this way. Y is greater than or equal to -2. Is it okay to write them separately? Sure. I don't care. I'm just showing you how to write them together. If you want to say, okay, Y is less than or equal to 2 and Y is greater than or equal to -2, is that saying the same thing? Yeah, that's fine. Write it that way if you're more comfortable with it. Doesn't matter to me. I'm more concerned that you know what domain and range are. Okay? Do you feel that you know what domain and range are? Getting close. How about this one then? Domain and range. And then we're done. Once again, this is how the graphing calculator does it. Does it show you something very important? No, it kind of, but we know this is secants. We know this has what in it? This has asymptotes. Can you kind of see where they are? Yeah, okay, it's right here. And obviously there'd be another one over here, right? Huh. So in this case, are all, well, another one over here, obviously. Do all X values get graphed? No, they don't. So can you say that all values get graphed? Oh. Here's how I would do it. You don't have to do it this way. All reals except, that's an E, sorry. And then basically say where the asymptotes are. Do the asymptotes continue to happen over and over and over again? Do they happen at a regular interval? So can we go back to kind of what we were doing back here if it happens at a regular interval? Can we use K to help us out? Yeah, well, let's let K help us out. So find the first occurrence, whichever one you want to use. I would probably use this one right here. And where is that? 45, except 45 degrees plus, now how often do they happen? Yeah, plus 180 degrees, K. And again, we're going to say that in here, K is understood to be an integer. Range. It's kind of different. Here's 1, 2. So this is kind of the 2 threshold. So I would say that Y has to now be less than or equal to, because it's got to go this way, right? It's got to be less than or equal to -2, and Y has to be greater than or equal to, because it's got to be all of these greater than or equal to +2.